Alright, in this lesson 4.6 we're going to talk about the set of complex numbers. We're going to learn about the imaginary unit I, complex numbers, how to add them, subtract them, and multiply them. First thing we need to talk about is the imaginary unit I. But before we do that, let me remind you that when we have an equation like x squared equals, let's say, 81, we have two solutions to that. Because the solutions are going to be the square root of 81 and the negative square root of 81. So we just take the square root of both sides to undo the square, and we get x equals plus or minus 9. So we have a positive 9. 9 times 9 is 81. Negative 9 times negative 9 is also 81. So two solutions. But when we have an equation like x squared equals negative 3, there are no real numbers that are going to satisfy that equation. No real number solutions. Because if I have a positive squared, it's going to be a positive. If I have a negative squared, it's going to be a positive. So the solutions to this are not real numbers. There are solutions, but they are not real numbers. Now, if you do not have the note packet, these are the notes that you should be writing down, the stuff that I'm going to write down. I'll show you what you need to write. If you have the packet, you can just take notes on the packet. But if you don't have the packet, write the notes on your own paper. X squared equals negative 3 does have solutions. We do the square root to undo the square. We do a plus or minus square root of negative 3. And we do get two solutions, but they are not real numbers. So we're going to build a new system of numbers called the complex number system that will give us solutions to equations like x squared equals negative 3. So we're going to start with the imaginary unit I. Imaginary unit I. And if you have the note packet, you can just underline the important things or highlight them somehow. But the imaginary unit I is defined as the square root of negative 1, and it is not a real number. I do want you to notice that because I is the square root of negative 1, I squared will be negative 1, just like when we have the square root of, let's say, 16. That is 4, because 4 squared is 16. It's the same idea. The other thing that we need to know is if we have a positive number r, a positive real number, the square root of negative r, we're going to simplify that by bringing the negative out as an I, and making it I times the square root of r. That's this right here. So if you have the note packet, you can just highlight that idea. And then I want you to notice that if we take I times the square root of r and we square it, we get negative r. And an example of that, well, let's just go down here and do some examples. Example 1. Square root of negative 25. We're going to do negative 1 part A. To simplify or find the square root of negative 25, we bring the negative out as an I, and then we simplify the square root of 25. But because 25 square root of 25 is 5, we have I times 5, but we're going to write the 5 in front. Just like instead of writing x5, we write 5x. We're going to treat the I very much like a variable with the extra twist. And here's the trick, people. When you are working with complex numbers with the imaginary unit I, you treat the I like a variable, except you're always going to simplify an I squared to a negative 1. So I'll show you how that works as we do some examples. Let's do the next part. Part B, square root of negative 72. So the negative is going to come out as an I, So we have I times the square root of 72. And then we're going to divide the 72 by 2 and have 2 times the square root of 36. So we have I times the square root of 2 times 36. We'll use our product property of radicals to say the square root of 36 is 6, so it comes out. And we have 6i times the square root of 2. We don't put the I behind the square root because we don't want it to look like the I is underneath. The I is not under the radical. So we'll put the I in front of the square root, but notice how it's behind the 6. That's the standard way of writing it. Okay, part C, negative 5 times the square root of negative 9. So with this one, this negative right here, the negative that's under the radical, is going to come out as an I. Notice I'm not doing a negative times a negative and turning it into a positive. That's not what's happening here. Negative comes out of the radical as an I. We have negative 5i times the square root of 9. Square root of 9 is 3. So we have negative 5i times 3. Remember, treat the I like a variable. So we're going to do 3 times negative 5 and make that negative 15 times I. And there we have it. Okay, I'm going to ask you to pause the video if you need some practice. You can pause the video, do the monitoring progress problems, and then check your solutions with what I'm going to have. Okay, check your answers for the monitoring progress if you did them. I do want to talk just a little bit about a couple of these. This one is 2i times the square root of 3. Second one is 2i times the square root of 3. The third one, the negative comes out from under the radical as an I, and we have negative I times the square root of 36 because there was a negative out here. So negative I times the square root of 36, and then we have negative I times 6, which is negative 6i. And the last one, just follow how to simplify the square root of 54. Okay, let's talk about the set of complex numbers. So the set of complex numbers includes all of the real numbers, and then it includes all numbers of the form a plus bi. So the set of complex numbers includes all the real numbers, and then it includes numbers of the form a plus bi, where I is the square root of negative 1. Let me write that a little better. So a complex number is a number of the form a plus bi. So a plus bi is a complex number. Complex number. A and b are real. I is the square root of negative 1. So if a and b are real, a and b are real numbers, and I is the square root of negative 1. When we look at a plus bi, the a is called the real part, the b is called the imaginary part, and as we said, the I is the square root of negative 1. Okay? If a equals 0, so if you have a complex number that looks like just b times I, that is called a pure imaginary number. So things like negative 4i, that's a pure imaginary number. 6i, that is a pure imaginary number. And that is the first page of our notes.